Hello everybody, start from this video. I'm going to talk about machine control PLC programming. Right, that is, how do we program PLC with ladder logic to control the machines. I'm going to use a station. That's basically what we call the machines. This station has drill and clamp. That's what we call toolings. So you can see here, that's the drill, and that's the clamp in there. Alright, so first let me just start a demo. Let me set that here. So over here on the corner you can see this is the drill station, and we use that to clamp to hold the part, then drill the hole on the part. Alright, so that's what we want to do with this machine, with the station. So first we can put the machine in different mode. Right now you can see at here it says auto mode. That's what we will do automatically. But of course at the beginning you can also set up into manual mode. So once you go into the manual mode, you will be able to move the tooling by pressing different buttons. For example, I can close the clamp. You can see here right now it's open. When I hold it, the clamp start to move. I can also move the drill up and down. So for example, I want to lower it, I can press and hold the button on the HMI to move the tooling. And if you want, you can have one button to control all the toolings. So both tooling will go back to their initial position. The drill go to the higher position, the upper, and clamp open. Once we home it, is that indication is home, manual homed. Then I can set it into auto mode and cycle start, because once we are going to the auto mode, everything will do automatically, and I can load the part. Then from now on I don't have to control anything. Your PLC logic should control the machine to do the work automatically. So you can see clamp close first, then drill come down, then clamp hold it and drill go up to the home position. You will see drill cycled. Then after that, clamp will move back, finish what we call cycle, and then you will have a part ready. So you finish one part. So if the operator picked the part away, everything cleared, go back to the initial state. Then if you load the second part, so you don't have to do anything else, you just need to load the part. Once the part present, over here is a sensor, and then the machine cycle will repeat. Right? So that's basically what we will do with the PLC programming. Of course, we will go step by step. Right? So we won't go to the very complicated situation first. Right? So we'll start with simple one. So, okay, so let me set up here so we can go back to the version 1. I'm going to start on that. Okay, let's go back to here. Their last topic, we're going to talk about it. Alright, so over here, that's the list. So first, we will go a little bit review. Start from those two labs. Right, so we talk about the garage door. That's one of the lab. On the lecture and also on the test, we also talk about the conveyor. Remember, we load the part on the conveyor, right, the motor start, and by those two design, we use what we call the truth table method. So we'll do a little bit of review with that, then move on with the drill station. So with drill station, we're going to use UDT to organize our tags. Alright, so we will talk about that on the lecture with UDT. We also have the UDT with the trivia game. Right, so that's what we will use with the drill station. Like I mentioned, we will start a simple version. For example, we don't need to have a clamp. We only need to have a drill up and down. So we will look at that. And from that example, I will introduce this what we call the sequence bit, that method. So up to this point, pretty much that's everything we can talk about with video 1. And after that, I plan to have another video to talk about the sequence bit design for drill and clamp, both of them. Right. And the other video will be on the step logic. And the final one will talk about the other concepts of the machine control, buffering I/O, and handshake. Right. So that's what we will do with the demo and the videos. Right. Let's start from here. Remember, that's the what we practice with the garage door. Right? So we have operator interface, push buttons, and also the sensors up and down. Right? With output, we have 2 of them. So one is motor up, the other one is motor down. Right? So that's what we have with a motor control. Right? I'm going to do the next slide. Yeah. So with the next slide, that's the one we went through for the truth table. So basically, if we want to design to energize the motor up, right? So you can see that is this part. Right? We want to energize motor up. We want to have all the related input information put into a chart. So once we have all the information we have on here, we go through different steps. First step, we check the input type, normally open or normally close. Then for that, from there we figure out the active state and the tag value. And based on the tag value, either 0 or 1 on there, we decide the instruction we're going to use. Right. So that is the final design with the program ladder logic. I want to point out 2 of them, 2 of the skills we learned. One is called seal in, the other one is called interlock. With button pressed to energize the motor up, then we use this motor up tag. We use that back here. Right. So that's what we use that for seal in, to bypass the push buttons. Right. So that is the first one. For interlocks, we have 2 of them in this design. The first one is this one, up button and down button. Right. So we want to make sure when the up button pressed, in the same time nobody pressed the down button. So that's the interlock. That's why we have both check in the same time. The other interlock involve the output. In order to energize the motor up, in the same time the motor down, the opposite, shouldn't be energized. Right? In this way, we make sure there's no time we have up and down energized in the same time. That's the second example, the conveyor control. Right? With the conveyor control, we want to energize this motor, and the control device will be the buttons, 2 buttons, and drop sensor and peak sensor on here. Right? So that's the logic, and you can see here that's also the truth table method we go through for the steps. Right? So it just lets you know that we learned all those techniques, and we continue to use these techniques in the following design. Right? And particularly in this example, we create a brand new tag called run in order to hold the button states, and then we carry on this run into the second branch here. Right, so that's one technique we learned, we want to create new tags. When the logic become complicated, and we use that new tags to hold the intermediate logic result. So that's what we learned. So over here I put a reference. All right, it's a textbook. The author is called Hugh Jack. That's the link. You can look at the PDF. We don't have to read all this, but I just want to point out. All right, so that's the point the author trying to make. All right, so let's see here. You can see here, a well-designed program requires less time because we want spend time for the design, right? Not instead of debug and troubleshoot, right? So that's why the author mentioned that spend as much time on the design of the program as possible, and that is what we will do with the machine control. From this example, we will spend lots time on the program design instead of real coding, because that's the key in order to make a very high quality program. Next slide. Over here the author gave a chart, and it include all kinds of different PLC programming techniques. All right. As you can see here, with different type of program, the problem, we should choose. Ideally, we should choose different way to program it. We will focus on here. With very clear steps, we will use sequence bits. So that's what we will learn first. Then we will also introduce one concept. It's called step logic, but we don't use the flow chart. All right. So if you're interested, you can look at those parts by yourself. Also include all this method they mentioned. You can look at from the textbook. And later on, probably I will talk about a little bit on this SFC, sequential function chart. So that's something with the Studio 5000 we can learn from there. Okay. First, that's the example I show you at the beginning of the video. Alright, so that's just an interface for you to use reference. I just want to point out over here, for safety design, you should focus on the hardware device and not in the data logic. From the design, you can see here we include some features for the safety concern, but you shouldn't rely only on the software. You should have the hardware device in place to maintain the machine safety. Right. For the UDTs, right. With UDT, that's how we organize our tags. We will first create one tag called station, and the type we create is also called station. Then the other UDT type is called cylinders. Right. We just assume those two toolings. We have a cylinder to attach on that. One is called drill, the other one is called clamp. And the details on these two UDT, you can see here with station, that's all the members on here. You don't have to understand all those tags at the beginning, but later on in the logic, we will start to use all the tags in here. With cylinder, you can see that's the generic design, the data with the cylinders. So for example, you have the retract proxy, extend proxy to indicate the position. You also have two output similar to the garage door, retract and extend. Of course, we also have push buttons as a menu function, right? So when the operator press buttons, you can move the tooling. Like I said, for now you don't have to understand all the tags, but almost all of them we will start to use that very soon in the logic. The first version we're going to design is called the drill only. So we only have one drill. So over here, that's the only one tooling. There's no clamp. You can see here, no clamp. So we only control the tooling, the drill up and down, right? So that's what we will do with the logic. First concept is the mold, right? So you notice that I put the machine into two different modes, right? Of course, they can have even more on top of that. Those are the two basic ones: manual mode and auto mode. And they should interlock to each other, because when you are in the manual mode, you don't want a machine in the auto mode, right? They are mutually exclusive to each other, right? And the other thing is that you don't want to use large and large to energize the mode. We talk about the large and large, right? So for example, if you large the machine into auto mode, right, you can run the machine no problem. But suddenly, if you lose power, right, your PLC power off and then power back on, and then with the large, you are still in the auto mode, and that's very dangerous with your machine control, right? Because you lose power, you don't know what exactly of the state of your machine. You don't want your program automatically go into auto mode, right? So that's understandable. That's why we don't want to use the OTL, OTU. So instead, you can see here we use. I still have trouble with this highlighter. So this here with the manual mode and auto mode on here, we use the OTE. And similar to the garage door, we have interlocks. Right? One is the output interlock. You can see here, whenever you want to energize the manual mode, and in the auto mode should be off. Right? Same thing for auto mode. Before you energize auto, you need to check manual mode is off. And with push button, same thing. If you press the manual button, you need to make sure the auto button is not being pressed. Right. So that's what we talked about at the beginning. And part present, from the demo, you already see that, right? So that indicate there's a part in the machine, right? So you can start machine with the initial position, or we call home, right? Similar to robot. Later on we will talk about when we have robot, it's also initial position is the home. So the operation sequence continue until the part being processed. So once we process, that's called one cycle. That's what you will hear me talk about a lot, about cycle, right? So for example, when you start, that's cycle start, and then you will have a cycle complete at the end. Right. So other time, maybe you hear cycle time and out of sequence, cycle out of sequence, something like that, right? So that's basically talk about the process of your machine. So let's focus on these two modes first. Right. I want to show you one of the design on here. Let me see here. Let's look at here. So that's the first design. I want you to look at it. So you can see here, first we have two different modes with machine, right? So we have the station manual mode, auto mode. Then once we are in the manual mode, the push button will control the tooling, and the auto mode, we will have different logic to control the the drill extend and retract.
Okay.
So that's the design we have to retract the drill. So for example, I want to energize that, retract to the top, right? So I need press the raise button. You can see here, right? So manual mode, retract button. When I press, but I don't see the output turn on, right? So that's one of the problem with the design in different mode. So the reason here, some of you probably already realize, that's the typical problem we talked about before, double coil. Right? Because we have two different modes, but when you have two separate mode, manual mode, here auto mode, it's very natural you try to design that on different runs. But realize here, the same output is being energized in two separate runs. That's what we call the double coil syndrome. Right? So that's why we have to be aware. With two different modes, we want to avoid the double coil syndrome. Right? So let's go back here. Then let's look at the truth table design for that. Over here, I'm trying to extend the drill. Right? Of course, we design that in the auto mode. It has to be on, right? So that's one. Part has to be here. Part present is on. Then we're trying to get the extend position similar to for the garage door. We have to check the target if that proxy sensor being made. Right? So that's pretty understandable. We have to figure out those tags. Over here, I just put this. Is when you try to extend the drill, do we need to check the retract proxy? Right, so that's my question. Is that necessary? Similar to this, whenever we want to energize the retract, do we need to check the extend proxy? Is that necessary? So that's my question. Right? It's understandable when you try to energize the retract, you want to check the retract proxy if it's on. Right? If it's not on, you want to energize it. But when it's on, it's activated. That means you're at the position. You don't have to keep going, right? But with those two, do we really need to include them? So if we don't, see what happens out here. So if we don't include the initial position check, we will have a problem. Both outputs are energized in the same time. The drill will stuck in the middle. Right? So that's the program design without initial position. I can show you that on the program. Alright, so let me just set up here. No initial position. That's the version I set it up. Okay, so that's alright. So let's see here. If we set up into manual mode, you can see here. In this design, we solve the problem, right? So we solve the double coil problem. We combine auto and manual into one run, right? So that's over here. We press the button. We can extend the drill to the top position. All right. So you can see we're ready to go with auto mode. So if we press auto, load part, you can see here part present, then you can see here the drill extend output and retract output both on at the same time. Right? So that's why we need include initial position. If we don't have that, that's what we see on here, both energized, and then your machine got stuck. Alright, I think this video is long enough, too long, and I'll stop here, and then I'll continue next topic in the next video.